All right, in this video, I'm just going to quickly show you how I use MeasureQuick on a maintenance, routine maintenance, or even a service call. Just a full run through. Yeah, there are going to be cuts and edits, but it's just going to be pretty much the whole run through of MeasureQuick. Like I said, it's a really powerful app. Yeah, they just changed the pricing model on it. I think it's probably, it's a little steep, but honestly, if they can integrate it a little bit better with House Call Pro, it'll be worth it. It's a no-brainer. My thing is, or our thing in the company I'm working for, is basically just the ability to fully transpose the property, all the equipment profile information over to a property profile within the CRM. If they could do that rather than just kind of, exporting PDFs over and a bunch of pictures in the attachments, then I think that would make it a absolute no-brainer for absolutely any company. Save at least 2 to 5 minutes, I guess, per call. You use it basically on every call. It's a no-brainer. It'll definitely pay for itself in no time. But I feel like the integration with the CRMs is super important to make companies and business owners actually see the value in that. Otherwise, I still think it's pretty good. I still think it's a pretty fair price. Other than that, just stay tuned. I'm about to show you how I go through the full MeasureQuick process on a maintenance. All right, stay tuned. Crown over there, one up here. Okay, I'm just going to quickly do a MeasureQuick project rundown from start to finish. So what I'm going to do is just quickly exit. You always want to be exited out of your project you're in. And I'm just going to select 6081. It's the project. So it's going to be a AC pump service. Let's just say no equipment. So I want to create new equipment for this site. Okay. Let's go ahead and put my screen recorder on as well. First thing I want to do is just hit my AI profiler here. So we just grab our evaporator coil here. And I like to just get only the coil data as well. If I can get close enough to be able to achieve that. Now, zoom in a bit. Try to get as little of any other data as possible. Yeah, it's hard to keep that sucker still. Okay, got that. Take a picture from a couple feet back. Grab a picture of the filter media. We got a 20 by 24. There we go. We have the luxury of the outside unit being pretty much right out here. We'll grab that. Alright, so we got all the pics we need. Get back to MeasureQuick. just going to go to our library. Outdoor unit, select that. Oh, yes, please. Yes, if you don't mind turning it all the way down. Thank you. Furnace. HVAC coil. And filter. Alright, so that's all the pictures we're going to need to profile it. So this is one of my favorite new features of MeasureQuick. They just added, I think, the last 2 revisions or so. And it's essentially an algorithm that allows you to upload pictures of the data plates. So for a split system like this, for instance, it's a gas furnace. It'll need the picture of the furnace data plate, evaporator coil, and the outdoor condenser. I also take a picture of the primary filter as well, and that gives me, that'll pull out the information for the filter face velocity. But the algorithm is going to extract all the pertinent information, i.e. the system capacity, model number, serial number, refrigerant type, basically all the information that's needed to make MeasureQuick actually function accurately. Like Jim always says, garbage in, garbage out. So this actually makes it a lot quicker and a lot more accurate experience when using MeasureQuick. So yeah, definitely super thumbs up on this. I've been loving it so far. It's probably about 99% accurate thus far. Haven't had many hiccups on it, so shout out to the team at MeasureQuick. It's definitely a sweet program. Now we're just going to go ahead and hit ID and profile. Oh, missing information, my apologies. So you got to hit up here, split. It's a split system. That's a cooling with gas heat. Profile system. So let's take a second while that's doing its thing. I'm going to go ahead and I've already deployed my cyclometers. It's the first thing I do anytime I'm any call them at maintenance or service. So this is just the maintenance, one-time maintenance. So go ahead and zero out both of them. Thick one I use for the return, skinny one supply. So, oh yeah, that was successful. So as you can see, all of our information has been filled out. We'll go through and make sure all that's accurate, but I'm pretty sure pictures were good enough to where I'm pretty sure that was good. Filter media. Alright, everything looks good. So, alright, so I'm just going to go ahead and pop my return probe in. What's that? So you want to grab total supply static, make sure the arrow is facing in the direction of the airflow. You can hear the static pressure is pretty aggressive just by the sound of the system, if you hear it. So now if you look, anytime you hear a system rumbling like that, you know this is a 3-zone system. Only one zone is calling. So in the meantime, we just open up the other 2 zones so you heard it quieted down. We're going to see our static pressures. Awesome, thank you. See our static pressures decrease dramatically. And as well, to combat that, we're going to make sure this filter arrow's in the wrong direction. No big deal. That filter's still clean. I'm going to flip it around for him though. It hasn't been in here that long, so it's fine. Must have just changed it. You always want the arrow facing the unit. Not the end of the world if not, though, truth be told. Okay, so we still have a 0.96 total static even with all the zones open. And that's what you get. So hold our supply temperatures. Let's see what type of. I don't think that was a 2-ton. I don't know why this thing didn't properly profile my capacity. Let me see here. That's a 2.5 ton. Huh. Also believe it's a 2016 as well. Oh no, it's 2014. So you want to go ahead and change whatever things need to be changed. 2.5 ton. Coil is not oversized. Keep that. Furnace, you want to see what your furnace drive is. So that's going to be embedded in the model number. So it's going to be a serial number. Yeah, the model, sorry. 14. That's a 3.5 ton drive, I believe. 14. Alright, so next we're going to make sure we saved our, saved our static pressures. Grab our manometers. These don't need to be in the whole time. Put those away. So now I'm going to grab my redfish meter here. Just going to check our blower wattage. I'm going to use this just because it's integrated within MeasureQuick. And this is a MeasureQuick demonstration, right? So kilowatts. I'm just going to go ahead and grab my. I'm just going to grab the line wire there. And then in order to grab my voltages, just open up this here panel. Let's go ahead and electrical. So you see automatically registered. So I'll have to make sure it's a PSC mode. I'm not sure all my data is accurate there. So then I just go ahead and take these leads. Put the red one in the black, and the black one in the white. We've got our 120 volts, power factor 0.76. That's 570 watts. Now I wanted to capture this because this demonstrates perfectly what I always talk about, why watt meter, a power meter is so important. Because when you're talking in SEER, when we're speaking the language of SEER, they're not concerned about amp draw. It's more of a power to BTU ratio. Wattage consumed for the amount of BTUs provided. So essentially, you're looking at this being a 2.5 ton system. It's a pretty round number, 1,000 CFM total that needs to be pushed out of this system. So based off of certain energy commission standards, you don't want any more than half a watt per CFM coming from your blower motor. So this is a perfect example because it's a dead flat 1,000 CFM. And we're at 560 watts. So we're above that threshold. We want to be 500 watts or below. This is something that just you're not going to be able to know by checking amp draw alone, because it all varies. Everything's going to depend on that power factor. If you had a power factor of a 0.5, then that means you're only pulling, if it was 500 watts, it means you're only pulling 250 watts. Now, if you had a power factor of 0.99 or unity, then that means you'd be pulling the whole 500 watts. So most of the times, especially with ECM motors, you're going to need a true power meter, even PSC motors, because most of the times if that capacitor is not properly sized, or if it wasn't, if it's low or something, you're not going to be at that 0.96 or 0.95 or above where it should be close to unity. But yeah, I just thought this was a perfect opportunity to illustrate what a proper performing blower motor would look like and what an improper performing blower motor looks like. So if you have 1,000 CFM, 2.5 ton system, and you're above 500 watts, you need to take a look and look a little bit deeper under the hood, see what's going on. And like I said, the lower the better, but sometimes it can even get a little bit too low. You don't want to be probably below 0.2 per CFM. Hit capture, evaporator fan. And that's captured. Now this measurement of the 563 watts, that's going to be able to tell me when I go here to my fan efficacy. More than likely, this is, with it being a 3.5 ton drive, it's running in high. As you can see, we got a 0.5 current. Our design target is at 0.50. So it's basically, fan efficacy is your wattage divided by your CFM. So essentially you want about a half a watt per CFM. Okay. We've got a little more than half a watt, so we're a little high. Look at our static pressure off the charts. So we pretty much finished up inside. Now I want to go ahead and go to the condenser fan. I'm going to still check the blower compartment and everything. Okay, so we're outside. First thing I'm going to do, temperature clamps. Those things take the longest to stabilize. So I'm going to pop my temperature clamps on the lines. Now when I'm getting off my, getting my suction lines and everything on, they should be nice and stable. Now we grab our pressures. Cool. Now we can go ahead and, one last thing. Outdoor temperature sensor. It's all shaded today, this morning, so we're good. It's a little chilly out, I'm not gonna lie, over doing maintenance, but it should be okay. So now let's take a look here. We've got 11.6 degrees subcooling. We can just go back to our profile, look at our outdoor unit picture, view photo, and it's saying our subcooling should be 10 degrees, so we're on the money. And that's been registered as here as well, so that's good. So we got 11 degrees there. Okay, outdoor temperature, good. Liquid line 60. Pressure ratio low. Let's go ahead and hold that and see what our temp split is. Now, let's grab our electrical data. Cool. Once again, grab the redfish. Still booted. We're just going to go ahead and do the same exact thing. Right now I'm looking for, I want to put the clamp on the actual line coming in. Line voltage. Take our, go to electrical. And now we'll see down here, 5.3 amps. Let's put our volt, and we're going to do the same with the voltage. So we got 1300 watts, 245 volts, 0.98 power factor, which is great. I'm going to save that. So now all my electrical is captured. Everything for this system has been captured beautifully. I think this might be a high efficiency coil, 13 to 16 SEER. I don't know, it's a standard coil. It's probably just a little cold out, to be honest with you. So now I'm just going through and taking pictures of, for instance, air distribution. I'm going to take a photo here of this zone board, right? Whatever, use photo. Drain line. Take a few pictures of the condensate drain system, right? Take photo. Use photo. Maybe take another photo a little bit further back where you can see both of them. Air filtration, air distribution, do another one there. Take a photo of that mess. So I'm gonna go ahead and cut the disconnect here. We're gonna do, and that way we're not freezing the place out. Check our true flow. All right, got a little bit of a surprise here for us. I'm just going to check the total airflow here. That way we can know for a fact our MeasureQuick SEER rating and everything are accurate and true. So that's going to be a 25 by 20. Oh, sorry, 24 by 20. Got our 24 by 20 plate. Power it up, lock it in. Cool. Grab our manometer. It's going to be the, power that thing up, DG8. Alright. Wank that right there. What I'm going to do is just pop a hole real quick right in front of him. Pretty good spot for it actually right there. Perfect. It's got an automatic zeroing. This manometer does, so I can put it in and leave it in. It'll just maintain the proper static pressure. Now, if you can see that right there is not good. 0.4 inches on the supply itself. All the zones are open. So it's pretty crazy to me. But that's zone systems here in the Carolinas. It's par for the course. So we've got all that integrated. We got our stuff set up here. Now what we're going to want to do, go back to MeasureQuick. I'm just going to go to my toolbox and activate my true flow. Okay. Go back to gauges. I'm going to say use true flow for airflow. Open that up. So here we go. Run test for MeasureQuick. Perform real test. Select that. Select that. It's cooling mode. It's a furnace in the upflow position, as you can see. MeasureQuick has already selected everything. Just need to select my air filter, and it's a filter slot, induct, or cabinet. So we're just going to select that. Alright. Don't show that again. Oh, it's doing everything. Alright, so, which I like this better anyway. I like getting the whole profile. I'm go ahead and drill a hole here. Going before the filter, after the filter. So add that there. So before the filter we're showing 0.225, oh, 0.3, that's crazy. For the filter we're showing 0.3. Take measurement. Let it capture. After the filter, we're going to do right here. .42. Take measurement. Okay. Before the evaporator coil, right? So we're gonna go right there. Perfect. Oh, yeah, my 0.52. Take measurement. And then last but not least, after the coil. So 0.52 is there. Now we're going to see. Okay. Here we've got 0.4. Take the measurement. Now we get our flow grid ready. We want the logo and everything facing the airflow, meaning the airflow should be hitting that logo. And there is a, say there, air in. Let's hit continue. Let's go ahead and throw our plate in here. Alright, got it in. Oh, cool. Airflows 1084. 1100 CFM. Take the measurement. That's nice. Continue. Workflow complete. Save that. So yeah, it gives you all your breakdown. Airflow is a bit high, so we can adjust that fan speed tab. I'll do that before we go. And static pressure is off the charts. We're going to go ahead and hit continue to MeasureQuick. Cool. So now we've got the true airflow. 1093 CFM, which that makes more sense. We've got all of our indoor static pressures. Let's click here, see what we've got here. Load odor on evaporator, that's true. Sensible capacity below 90%. Potential return air duct leak. There needs to not. One thing, guys over at MeasureQuick, if you select gas furnace cooling, just get rid of anything to do with energized heat strips, because it's not it's just not even relevant. But there's something to think about, food for thought. Other than that, this thing is looking beautiful. Fan efficacy, as you can see, and this is what I mean when I say like the fan efficacy is telling you the fan speed is set too high. So we've got multiple indicators showing that our fan is set too high. One, airflow is above what it should be. Temp split's lower than it should be. Two, static pressure higher than it should be. And last but finally, fan efficacy, meaning our watts our watts per CFM is more than it should be. So let's go ahead and open her up. So you can tell that blower is desperately trying to move, you know, that 1400 CFM. That's an ECM motor. Okay. Yeah, as you can see, ECM. Let's take a look and see what our speed taps are doing. Cool is gray. So here you can see that gray is for cooling, tap 5. I'm going to use yellow for cool instead, and that's going to give us a little, it's going to help to make that motor last a bit longer, as well as just do a little bit better in dehumidification. So yellow is going to be speed tap 4. So what we're going to do now is grab our gray, wire off for cooling. That is on there really good. Don't want to break that. I'm just going to quickly, that's weak. Okay, gray's off, and we're going to use yellow, right? Yellow is going to be speed tap. Yep, number 4. Grab the yellow off the spare. Okay. Put that on cool. Might be a little bit blown out. Now we're just going to put our gray on the spare. That's pretty much what we got. As you can see, as you swipe down, it's a lot better with the iPad as far as the viewing. So as you swipe down, we can see we've been going for 32 minutes. Low load on the evaporator, potential return, that's not right. Static pressure is high for sure. Now look at this here. 48%, we got an F. Age and efficiency losses, docked us 20 points. Temp split losses, that's from the high airflow. Static losses, another 23 points. I'm going to hit a generate vitals. Finish on that. And now we're going to go ahead and hit corrective actions. The only thing I've done, I'm just going to say adjusted airflow. So we're going to say air distribution, adjusted fan speed. That's all I've done. Generate report. Say that was called Pro. So what I am going to do is check the wattage again. So right now it's showing the wattage of what the condenser is, because it's just, I don't have a capture on the condenser. As you can see before, this is what I captured for the blower. 563 watts, 6.2 amps, at a power factor of 0.76. Now the blower is currently doing 437 watts. All right, just some quick, simple math. Let's just say you run your air conditioner around 10 hours a day on average, costing around 15 cents per kilowatt hour. All you need to do is 126 divided by 1,000. That gives you 0.26 kilowatt hours. All right. Now all you need to do is take that, multiply it times 10 hours for the day. You get 1.26 kilowatt hours. Then you simply multiply it times the average kilowatt hour. Here, at least in the Carolinas, it's probably around 15 cents per kilowatt hour. Your 1.26 times 0.15, and you simply get basically 0.19. You take that times 30, that's the amount of days in a month. You pretty much save $5.67 a month. I mean, that's not the end of the world. That's not a crazy amount, but that's probably maybe 3 to 5% of your total AC budget. So it's not a slouch. So these are the reasons why doing maintenances are pretty important, and just making sure your system is getting the true SEER capacity. Now, don't get me wrong, you are getting a better sensible cooling with high airflow, so you are getting a little bit better SEER when your airflow is high like that, but you're also suffering on your latent end. So I'm just going to go ahead and screenshot that. Now what I'm going to do is clear and capture that. So basically, over 100 watts saved. It's going to also help to keep that blower motor lasting a lot longer as well. So that's why maintenance is important, people. All right, I'm going to quickly do a test out, see how much healthier the system is running now. So it's going to quickly capture our airflow again. Run test for MeasureQuick. Same thing. We go through the same procedure. For the filter, take measurement. I'm running it. We got 0.2. After, just quickly take measurement. 0.37, looking a little bit better thus far. See how quick we're doing it now. Take measurement. 0.44. Alright, supply. Was a 0.4, now it's a 0.33. It's much better. Can't wait to see what our airflow is. Get it set up. Done. Continue. I'm doing this because that way now our compressors, stabilizing, all our pressures are stabilizing, the voltage is at this point. Nice. 980 CFM. Take measurement. That's beautiful. That's where we want it to be. So we're not offending the blower motor as much. Going to get better latent capacity. Continue. Airflow complete. Save that. Oh yeah, now look at that. 0.81 is still kind of high on our static, but airflow is definitely in range now. Return, filter drop pressure is good. HVAC coil. Only thing that's high is the static plenum pressure. Okay. So we're just going to go ahead and continue to MeasureQuick. Return to MeasureQuick there. Look at that, beautiful. Continue. So now we're seeing, before our temp split was 16 degrees. Let's go ahead and reset our indoor psychrometers. 16.7. Okay, so I got my probes situated. Pressures, it's 20 degrees superheat, 12 degrees subcooling, looks good to me. 0 degree approach, whatever. Let's hold our indoor 16.4. The split never really changed much. And what I'm going to do now, last but not least, check our compressor watts one more time, or condenser watts, because it's going to be the fan, condenser fan motor along with compressor. So we put in kilowatts, that there. Head to electrical, and there you go. You can see 5.7 amps. Power factor 0.99. Capture that. Continue. So there we go. That's everything. Alright, so I went ahead and saved and tested out. I hit the save test out button, and now we can see air distribution still failed. Passed in the concentrate, outdoor equipment passed, indoor equipment passed, cooling capacity, I'd say it's fine. Like that. There you go. Generate report. Say that was called Pro. Everything's looking good. That's it. That's a pretty quick little demonstration on how to use MeasureQuick. Super fast, super efficient, and just makes the job a little more interesting. Gives you a little, just a little more details to work with, and lets you see everything that's going on in the system. But once again, you got to make that initial upfront investment. You know, get all your probes, psychrometers, all that stuff. But if not, I mean, it'll be a little more tedious. Kind of feel more like, you know, clerical, just typing in data, typing in numbers and stuff. You want that thing to just all integrate on you. You're not even have to think of any of that. Alright, let me know what you think on this video. Let me know what you think in the comments below. If this helped, if this pushed anyone over to actually becoming an avid MeasureQuick user, or if you already are a MeasureQuick user, let me know if you use it, you know, like this, or how you use it, how you've implemented it into your company. Other than that, pretty much it, gang. Trying to head on to the next call. We'll see you on the next one. Thanks for watching.